Okay. The worst kind of visitors are unexpected visitors. Alright, back to work. Yeah, so what even were we doing? Yeah, so now we just want to do, well, let's just make sure this is working again. Okay, this is, yeah, so I want to say, made like, made background shader have LP as a uniform instead of time. Okay. Since, yeah, I feel like in general, if there's any kind of like errors or any kind of debugging, basically impossible to debug anything on the GPU. So you just want to you want to move everything to like the most sensible programming language you can, which in our case is C. All right, so now that the background is working, zig out. Actually, why is the extra stuff in zig out? Zig out. So yeah, so now that that's working, we want to start getting textures in the game. So, so let's see, what did we do? So we had, yeah, so I think my initial idea is to get this as the tiles of the game should be the tiles of this image. We could change up the space theme a bit and use like an image of the moon or of Mars or something instead. But yeah, I actually kind of want to change the background colors from like a red to kind of like a gray instead. The red is just a bit too bright, especially if we're going via the kind of space theme. So we may as well just do that. Let's just pick a okay-ish gray. So instead of using this Kasama red, yes, I know there's an update needed, but not now. New, anything will do, whatever. We just want like the color picker. Here it is. So let's see. If we go for something more of a gray that's kind of like a dark purple. Could be a bit interesting. So I want something that kind of has a dark theme, but not just pure grayscale. I guess it can just be temporary. We will choose final colors at the end, but maybe like for now something looks like it still has too much color. Yeah, maybe we'll use this. All right, the values we want to hear, 6. We'll call this like off, or like blue black. Black for 0.6, 1.8. Well, this is. Why is there like 12.1? Why isn't this just the. What even is. This program. Internet again. RGB lights to normalize floats. No, of course I know how to. I just want to get this immediately. I feel like we should just do like a side quest that's just to like write our own program in Zig that would just do this conversion for us. This is happening enough times. Okay, the next time it happens, we will do this. Because I want to get the textures done. But after that, we'll just write a simple command line utility that does it, and then we never have to use any like ridiculous is this the one that we used? I think this was the one that worked, maybe. Okay. Okay. Yeah, we're totally doing the command line utility the next time. It would just be like color conversion.exe space hex enter. This comes up and then we copy and paste it. Okay, and then here we want blue black. So yeah, so now if we just like get rid of this and compile it again, it should at least be slightly more palatable. Yeah, this is more comfortable to look at. Okay, so the dots are now too close together. I kind of want it to be more sparse. If we're going for a darker background, I feel like instead of 7, we should maybe increase it to 10. Oh, no, 10 is... Ooh, let's open code life again and modify this. Like, we should be doing this at the end, but I kind of just want to do it now. Okay, so we get, let's make this a const, equal to this. Let's add in the LP as Yes, I know this is software update, not now. So yeah, the LP we just want to keep it to. Oh, I should have just set that as a constant. What am I doing? The thing we want to change is the reps and but also just the size, the radius. We do want to change this. Okay, so we'll make the radius 2 here. Make this a uniform const. This is to new. That's is what we want. It's the radius is too large. Okay. So before it was 7, and this was too close together. If we make it like a 5. Move the radius down a bit. I think I like this better. And then we still get our change. Okay. Let's paste these in. And then the reps set to 4. Okay. Oops. Oh dear. What did we just do? Yeah, wait, what? Why? Like, I didn't think we adjusted that much. Oh, we're getting a compile shader error. Syntax error expected identifier. What? Oh, yeah. Okay. Yeah, to me this looks better. Like when I'm staring at the grid now and moving this around, it doesn't seem as crowded as before. Okay, we'll keep that. No, don't say. Everything disappear. I don't need this anymore. Okay. Change background to blue, modified like widths. sizes. Okay. Now let's move on to the texture additions. So, I guess the OpenGL book would be a good place to start. I've forgotten the exact. Forgotten the commands. Zoom out. We know how coordinate geometry works. Okay. Oh, there's a lot of these like. There's a couple of extra parameters we'll need to pass. So here. None of the, okay. Here's some of, okay, so we need to, we have a U32, we need to generate a texture to it, bind it, set a bunch of parameters, then, okay, what is GL, what's the wrap S and wrap T? The second arg requires us to tell what option we want to set it for. Oh. Okay, what's the S-axis and what's the T-axis? Okay. I'm gonna guess S is the horizontal axis. So we don't want mirror repeat. In our case, we just, I guess the one we'll want is clamp to border. Yeah, we'll do clamp to border. If there's some way of like assigning the border color as a debug color, that would also be useful. Okay, and then so we do that on the axes, and then you don't want the blurry, so you just want nearest. The thing that every image viewer application seems to do like linear instead of nearest. Like nearest is what everyone wants. And then you want to be able to see the pixels, not blur them. And then yeah, why is there like 2 arguments to pass? But what's this like mag filter and this min filter? Texture filter can be sent for magnifying or minifying options. When scaling upwards or downwards, okay. In either case, both will be nearest. And then okay, that covers both of those. And then so yeah, create some like space for some state, set the state, and then what? We'll do our own version. We've already written our own image parser. We'll do that. We'll apply that. And then, okay, I guess here's the real, like, the real juice. When, 'cause, 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 we're not generating some bitmap. So we just want to say set tech image 2D. What are the args? GL tech image 2D. So 0 is level, which specifies the level of detail number. Okay, there's like map stuff that we don't care about, so that would just be 0. Internal format. Specifies the number of color components in the texture. Must be one of the base formats given in table 1. Okay. Ooh. I suppose it's going to be one of these, depending on how we pass it. I think, like, surely in the QRI image format, there's alpha values. So I guess it would just be this one. And then, that's so weird. Why would it only be RGB instead of RGBA? And then, okay, width, height, sure. Border, what's border? And presumably we're going to be using 0. This value, okay, it's just always 0. Okay. GL, RGB, formats appearing again. Why is format appearing twice? Okay. And then a type and data unsigned byte. Well, would it be anything other than unsigned byte? Oh, I guess it could be, or it could be float. So interesting. Okay. That would be quite inefficient way to store it, but okay. And then the data, presumably just to point it to the beginning. Okay. Are there any like are there any hidden bonuses when it comes to drawing this? Okay, update the stuff. Where's like all of the code? Okay, you can. I expect this is going to be really big. Oh, okay, I have to tell OpenGL to which texture unit each shader sampler belongs to. Okay, but that's like doing multiple textures. If we just want one, maybe this is all we need. So what's like the... So I guess it's possible to... What's this example doing? So it's using colors and texture coordinates at the same time. So it's saying store the texture coordinates as like a third input. Taking 2 floats, sure. Why are they doing this with 8? Because there's 8 per line, okay. And then 6, sure. So yeah, for the okay, so we're passing that into the texture coordinate, and then we're using texture, okay. So what is the texture, GL texture function? What does this do? Oh, it is overloaded. It is quite overloaded. What's the return type? A gvec for or a float. What is a gvec for? Okay, not telling me apparently. Something we can assign to a color. Alright, I guess that's all we need to know. Ooh, a uniform sampler 2D. So I guess this is where we had to call it below. On some drivers, it is required to assign a texture unit to each sampler uniform. Yeah, which is like the logical way to do that when you have the word uniform up here. Maybe it will just work on this computer. So yeah, we know, okay. Why is this uniform if we didn't need to assign it? Okay, Oh, quite a bit's going on here. So, okay, we can try and we can just try to get this. I am feeling uncomfortable with having like this uniform in the shader that we don't actually call from the main program. What are they actually suggesting? If we know how to set all of that up, that's fine. The question is what we can adjust the shaders so that they use this. That's fine as well. This is like an important part we can't leave out. Bind the texture before calling before the draw call. And it will automatically assign the texture to the shader sampler. Okay. So the claim is this is enough. But if not, then what? Okay, so this texture location is known as a texture unit. The default unit is 0, which is why we didn't do it to assign it. Okay. But not all graphic drivers will assign a default unit. After activating texture unit, a subsequent bind texture call will bind that to the active unit. This is always by default activated. Okay, so we didn't have to do it. Okay. Let's say we did want to control it. OpenGL should have a minimum of 16. Okay, so we just add in 2 there, do some obvious mixing, and then we want to specify stuff. Like, what if the height and data is different? Then what? Create another texture object, load the image, generate the final texture using tech image 2D. Okay, so we'd store it in some way. We'd store it somewhere different. Okay, and then you just want to bind it to texture 1 and texture 2. Okay. Like in this case, like since we're only drawing, well, currently, since we're only drawing a single texture, we won't have to get into this. But yeah, that's like we're already doing enough work as it is. So if we ever need to use more than one texture, we'll cross that bridge when we come to it. Let's get back into, well, let's start implementing this stuff now. So there was setup that we'll slightly want to modify, but general it was this. Okay, so let's see, go to main. When we do the setup array buffer, we want to set up the textures. Now, let's see, it would be good to like, let's start by importing like a QOI image. And I think we'll start by, we'll choose a really simple thing. Okay, so let's see, when we did our 4x4 Sudoku app, we had a bunch of like test images. It says this is QOI file that I think it was somewhat self-contained. Why am I using Windows thing? This file is a custom QI image decoder, yep. So how does this work again? Okay, we process the file at comp time to get all its header images, and then QOI to pixels is the thing we want. Okay. And then presumably within the QOI tests are some really simple images. Yeah. Oh, this is right. It doesn't. What's like the Zig image viewer? This is called Zig image viewer. Yeah. Okay, so say we do the red, 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 blue QRI. Yeah, which one do we want to use? Yeah, I reckon this will be like a simple, I think this is simple enough to tell us what's going on. Or maybe even what does the 3x4 look like? Or even this one, okay. Okay, so let's copy the 3x4 QI to the sliding puzzle. And then let's just copy all of this and move it into QI.z. Okay, so now it's here. Okay, so now I want to call this, where's the tests? 3, this is kind of what we want. And then presumably for the 3x4 we've loaded it up here, okay. Okay, so let's import QRI.z. Then we want to import the image. So we can do this before we init gfrw. Init QRI images. So why isn't it grid like after that? So init QRI images void. Yeah, so here we want to embed the images. So we want to say it's just 3x4 image. No, I can say this is just a temp. 3x4 image is equal to embed file. I think it was 3x4 QRI. And then once we've set that, okay, I disagree. Let's instead copy this. Was it like red, 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 blue QRI to here instead? And then this way it will be really easy to verify when we print out the pixels. Actually, that was unnecessary. It's only 12 pixels. We should be able to read stuff. We should be able to deprint it easily. So let's do an any. And yeah, let's try compiling this. The current build run. Oh, no, we don't want to do that one. Okay. Found a document comment. Oh, there's a difference between them. Oops. Undeclared identifier comptime header parser. Right, that is itself within QOI dot comptime header parser. Undeclared identifier pixel. This is just 4 bytes. I feel like the pixel should be a vector. So let's just store this as, let's just define it. Pixel is a vector for, well, no, we already have color as this type, so let's just change the pixel here to color. Undeclared identifier QOI to pixels. Okay, it's running, and what's this? Red something. Zig image view 3x4. So okay, is this? Do we see a match here? Red, black. Yes. Red, black. Oh, this is like gray. Oh, I guess it actually isn't black. White, green, gray. Yeah, that's good. It's fine. So, so in our case now we want to init the this image, the super famous blue marble image. Or in other words, what's it called? We'll call blue marble by blue marble bytes best, or maybe just blue marble QOI. Embed file assets blue marble.qi, and then down here we want to replace 3 by 4 with blue marble QI. Maybe we can clean this up a bit. Blue marble header is pass that thing. The width and the height. Blue marble pixels. Well, I feel like this should be called like blue marble. I want to call it blue marble bytes. That it's like it's maybe blue marble pixel bytes. I feel like that's a better description. And then we're passing that to yeah, blue marble pixel bytes. Okay. We can ignore this. The thing is, we kind of, if we're doing this at comp time, we shouldn't be calling this at this location within main. So we can just remove this line, I think. Yeah. Okay. So yeah, embed it, process it at comp time to get the header information, and then we should be good to go. So we can just print the header information in down here. Let's just try that. Print blue marble header pixels, and here we just want to say the blue marble header. Okay. Let's see, image width. It looks like it was, oh, okay. So here it says channel 3. So are we actually, is this actually storing this with an alpha channel? Maybe that's actually, I kind of, it hasn't been that long ago, but I've already forgotten the QI specification. Okay, so color space is 0, so yeah, it is sRGB. And yeah, I remember there's always like A's and everything. Hang on. Let's just like print out the first couple of bytes of this. It's like the easiest way to see. Let's say we just do, say, like the first 12, the first 3 pixels. Oops. Okay, I want any. Okay, it definitely is RGBA. Okay. At least in this case. Cool. So now that's in, we can. This isn't like init QI is a bit incorrect. I feel like this should be called decode. All of this stuff should be in the stack anyway. Everything except the actual decompression algorithm, which we want to do at runtime. If these are going to be usize anyway, I don't know why we're asing these. Like, why not just keep them? Why not keep them as is? Okay. Alright, we should not be defining globals called width and height. This is silly. Let's just write them both in here. Oh, actually, no. When it comes to some image processing, we may actually want the width of these things. Okay, so let's just say it's called like blue marble width, and what's the macro? No, not that. Oh, I've forgotten the keystrokes. How do you like type in multiple lines at one time? Isn't it like Control X RB? No. In either case. Decompress UI images. There we go. Okay. So much renaming. No, 189 doesn't know what width is. Wow. Okay, so now it should be in here, right? Yeah, a lot of colors that are basically like blacks, like 314, 425, yeah. So what did we just add? So I think in this case we can just remove all of the test QOI files. We're not referencing them anywhere else in here. So we want to, let's just delete them. Remove this 3x4, remove the RRB, but otherwise we can add everything else. So we can say decoded blue marble QI, to pixels at runtime. But without needing to use an allocator, since we can just look at at comp time, we can just figure out how big the image is. No need to have this. So in my head, that's the way it should be done. It should just be like the uncompressed, like the compressed thing should be in the binary, and then, but you already know ahead of time like how much space it's going to fill up, so you don't need to do any allocator stuff. In almost certainly many games have shipped where that is not the case. And it's been slightly slower as a result. So now we want to do well, now we want to render this. So we can do the back to this. We can now do this. Gen textures and at our. So when we go to the set up array buffers, where exactly in here do we want to do the texture stuff? I feel like the easiest thing to do while I'm still refreshing the memory of, well, any of this like OpenGL stuff is fiddly and can fail very easily. So I think I first want to just kind of follow this tutorial of mapping, including this texture information as part of an existing shader, getting that on the screen, and then as soon as we see the texture on the screen, we'll save that and then create a third shader program. Actually, we don't need to do that. I was going to say third shader program, so we have the colored vertices one, the background shader, and the texture. Oh no, we are gonna. So wait, so in the current game, so like the space inside each of these tiles, we're going to want to draw the texture on, but stuff like the border, the space, the borders themselves, we won't want a texture on, I think, or just yet, or maybe ever. Like we could create some texture for the borders, but that feels excessive and would probably still look tacky in some way. Yeah, in my mind, it still makes sense to have all of these as different shader programs, just like background, solid color, simple geometry, and textures. So we'll start incorporating textures into the current flat color shader. Then we will maybe duplicate that, and we'll just create a new one from that point on, and we will already have down. Yeah, we'll just get textures of working in some form, and then we'll separate them out. And when we do them in one form, we'll just follow this kind of tutorial. So let's set up the background first, and then do the flat color with the textures. All of that happens. This shouldn't actually change anything when we render. Let's see, current. Good, still the same. So now we want to add in this stuff. So we want to say add in texture. Say GL gen textures. Wow. We'll want to have a global for the for these. Where should we store this? Are we actually using this global via anymore? Okay. Delete this. So let's say we can probably call it blue marble texture. And what's this? Maybe we just call this like a texture ID. And then we should be able to alias. Oh, we already have texture in here. Okay. Texture. There. Okay. So now we do generate textures. Let's look up this function. GL gen textures, since it's like plural instead of one. Maybe the one is just referring to the number of textures we generate. Yeah. So we just want to generate one name, and yeah, the point is to where we want to do that. So generate one texture and store it at the blue marble texture. And then what? And we want to bind this. GL texture 2D. And this is the blue marble texture. Then we want to set the options. gl.tech parameter I. Again, what's this doing? Target name param. Oh, this is so overloaded. Oh, it's depends on the like float vector, unsigned integer vect. Okay, so parameter I, which is the simple one, is target pname param. Target pname. Okay, it's like some general. That's the general function for doing this. So yeah, gl.texture 2D. gl.texture wrap s. This is the one where we wanted the border instead of, what was it called? Clamp to border. No, why is this? Why is that part of the image instead of text? Clamp to border. And then I think we just repeat that, but with T here. Then repeat everything with T. Then what? gl.tech parameter I. Texture min filter linear. This is the one where we didn't want like the blurry. This is where every single image viewer known to humankind, except the one in Zig, uses linear, which is the incorrect choice. Instead, we want to use nearest. And then we do the same with the mag filter. Okay, let's see if that causes any whinging. No, that's fine. Yeah, so now we already have the array of uncompressed bytes. So now we want to, no need to fill like if data. Like, come on, like what kind of simple image program do you want to like figure out at runtime if the image exists or not? Like, just do it at compile time, embed it in the binary, and then it's portable. gl tech image 2D. So yeah, so instead of the RGB here, we want the RGBA. The width here, we want like the blue marble width, and like the blue marble height. Then, oh, maybe this is where we may need to do some conversions here. Okay. What's the type in this QRI header? Okay, it is unsigned U32s. What's the type of the width and height in GL Tech Image 2D? Is this also an unsigned 32-bit integer? Oh, it may be signed. I'm so annoyed with all of these like custom naming. Like, what is GL size I? Just say U32 or I32. Like, people are just tell me the number of bits, please. So it's actually signed. Okay. Well, maybe. Number of bits in this. Okay, GL is so ridiculous. GL size I. Okay. Finally, like. Keeping this a sensible name would have avoided me and likely hundreds of thousands of other programmers spending minutes to look it up. Anyway, we will need to convert this. What have been the other cases in which we have used the width? Blue marble. In the wrong file. What am I typing to? So yeah, we just used it in. This is the only place where I have to type it, I think. Note. the width and height of type gl, I've already forgotten the name, it's unhelpful, gl size i.e. I32. So let's call this like, what even should this be called? Maybe just texture width. Texture width is equal to an I32 that is, well, we need to cast marble width. And likewise, we want to do the same with the height. And then use both of those. And then what? Oh yeah, then it's 0 since the argument's always 0 apparently. And then it's a repeat of this because, of course, oh, this will likely be gl dot instead of gl dot rgba. Okay, gl unsigned byte, I think that's the one we wanted. No, where's tech image duty? Yeah, the type and then the pointer. Yeah, we're using unsigned bytes, so that's should be the same as this. GL. See if this if Zig existed back, if Zig existed before OpenGL, if OpenGL was made in Zig, all of this stuff could be done at comp time. It'd be a lot more efficient, be a lot faster. And the unsigned byte would just be a U8, not some string or enum, non-exhaustive enum, check behind the scenes. Okay, and then the data is just a pointer to the array, which, what did we call that? Was it glue marble pixel bytes? Zero. Okay. Huge function. Cool. Okay. Save. Let's make sure it still compiles. It doesn't. Binding says no member name. Tech image 2D. Okay. Other than that, it was okay. And then what? Okay, the texture should now, it's now in the GPU. So then we want to, well, actually it isn't. Or are we just storing a pointer to it locally? Unclear. Now we want to apply it. So this is the part where we'll just copy the example, almost verbatim. Well, adapting it is necessary. So they're saying add a third vertex attribute pointer, and then call it a text coordinate. So if we go into our or it's just a case of this thing up here. Temp, for now, add in the texture info as a third attribute. So yeah, we'll make this second. This is gonna. Doing this means we'll need to change the kind of the data that we're writing in this like vertex buffer. I think this is fine. I think this should still be doable. More work than I thought about ahead of time, but it should somewhat be okay. And now I'm being punished for setting this to be 5 instead of calling it just a constant that we could set. It's okay. We changed it in like a couple places. So okay, well, if we're adding in 2 extra coordinates, this is going to have to be 7. Okay, and then what's the offset? The offset is now 5. So all of these are 7s, and yeah, it's 2 floats. Okay, and then what are they saying? Oh yeah, never forget to enable these things. Okay, that sets that up. Let's just get it in the yeah, let's get in the vertex shader. The flat color. Okay, layout. Location is 2, and it's just a vec2 we're giving to it now. Chord. And let's leave it like this for the beginning. Well, let's just do it all. Let's just copy it. And then in the fragment shader for the flat color, this is where we want to use it in some way. And then through magic typing, it kind of knows that we don't need to specify the layout. I guess we can ignore the color to begin with. So we can just call this texture. Well, we need the uniform. Sampler 2D, our texture. Okay. This will result in a really weird looking image. iPad is low battery. Okay. And then back in main, we need to bind the texture before calling it. Okay. So in the render, once we draw the background, once we bind the stuff, maybe even we should use this program first. Now we want to say gl.bind texture, gl.texture 2D, blue marble texture. Okay. If we try and compile it now and run it, it will fail because we need to update the color buffer to this conglomerate, to this Frankensteinish thing. So now drawing a color rectangle involves adding in dummy coordinates for, well, involves adding in these like texture coordinates. Is there anything in this color vertex buffer that is... here's another instance of this 5 appearing. There may be some bugs we don't catch. Yeah, like this one, plus equals 6. Why plus equals 6 instead of plus equals 5? Oh, right, because it's 6 vertices. Okay, it's still... Oh no, there's the fact that we're using this magic number is... We are paying the price now. Because this color, like, I think we will be okay. It's just alarm bells are ringing in my head. But better that than no alarm bells at all. So let's just add in the extra. Oh, now we need to change color vertex. Oh gosh, this is nasty. So now we want to add in like texture X. It's in F32. Delete when working. And then texture Y. Let's just copy this. Okay. Oh, I'm almost concerned this isn't a pack struct, but it depends on how we're using this. We're not just doing a bit cast, are we? In which case we need to have know the memory layout. Wait, what are we doing? So we're creating all of these currently unpacked structs and then assigning them to this buffer, which is like, what's the type of this? It is of this color vertex type. Yeah, color vertex needs to be a pack struct. What do we do? Like, I'm surprised it's worked so far without, well, like the yeah. Actually, this needs to be called not pack. This is just meant to be an extern. The compiler is not allowed to change the memory order. It should be the same. Okay. 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 So now in all of these, we need to add in these coordinates. So good thing I called these x left and x right. So when we're dealing with the x left and y top, the coordinate should be -1, 1. Then if it's x right, it should be 1, 1. Then if it's x left, x bottom, it should be -1, -1. I guess we'll call this the same, and then x right, x bottom is 1, -1. Okay. I think that's it. Let's give it a go. Oh, this was just way more. Okay, and no textures being drawn. Great. Fun. So I think we do need to do the uniform thing. Unless, like, it was running. Yeah. Actually, if we add in, like, the frag color, this would tell us if something was failing too much. Okay. So yeah, definitely. So we didn't totally disrupt all of the other vertex shader stuff. It's just, yeah, this texture is not behaving. So what? Yeah, I think this is the case we've run into. On some drivers, it's required to assign a texture unit to each sampler uniform. Okay, so let's do that then. So yeah, after activating texture unit, a bind texture call. Yeah, so where exactly are we going to add this code? Activate texture unit first. Maybe we can do it down here. GL dot active texture GL dot texture 0, and then GL dot bind texture, like texture 2D, blue marble texture. Oh, it's like working hard. This doesn't seem correct. Why did it take so long to compile that time? We added in 2 extra lines of code. Which themselves was calling more behind the scenes. But we saw the result. The result was no texture. So yeah, this is just adding in or do we need to change, do we need to like set this when we after we switch the VBO? Like I wonder if that issue's happening. We may have to just call this GeoUniform one as well. Okay, render. Okay, so let's see. Once we using the flat color shader. Oh wait, we're already calling bind texture. Okay. Let's try it again. No. Okay. Like this stuff is compiling, right? Yeah. Right, we're gonna get a comp time fail if it doesn't. Well, the program will come to an end if it doesn't compile. We set that as unreachable. What do we need to do? Yes, there's this mix function, whatever. We now want to so I guess here's the key. We have to tell OpenGL which texture unit shader sampler belongs to by setting each sampler using GL uniform 1i, which we looked at before, right? Okay, so that's so yeah, what are they doing in this? So we're calling this, do we need to do this in the vertex flat color? No, what are we talking about? No. Let's just call this texture 0. Okay, and then we want to assign this uniform in here. So we want to say, we want to find the location, right? Texture 0 location, which is gl.get uniform location, shader ID. Okay, in this case that's just a flat color shader, and the name of it, texture 0. Oh, that's all it is. Then we actually want to set it. So now we want to say gl uniform 1i, and then the texture 0 location. Just set this to be 0. Okay. No, this was meant to work. Come on. That sucks. Now what? Unless it's like doing something where the reason it's black is because it's like working, but it's black because it's like zooming on part of the image that's like really dark, and there's some weird stretching thing going on. What if we called this like we have to copy it again, but what if we called this let's say we copied in the 4x4 Sudoku the RR in the QI tests, we copied the red, blue one and moved it to the sliding puzzle. Then, yeah, and then we just call this, and then we make this one red, blue dot QI. Next 12 out of bounds for array length 4. Oh yeah, I hear that. That is true, but we don't need that anymore. Okay, so the texture is actually loading. That's really good to know. It's just the zoom level was completely incorrect. Okay. So maybe we actually didn't need to do all of that uniform stuff. In either case, this is great. It's almost working. We're like 95% of the way there. We just need to scale it correctly. So, so what's happening with this scaling? Why? Because when we were setting these coordinates to be like -1 and stuff, Well, I was gonna say, those were just getting like massively shrunk, but we're not actually, um, it's a different texture coordinate, so we're just like, we're passing it on. Uh, um, Alright, what are the coordinates we're meant to pass in? Is it expecting the texture has already been normalized, or is it wanting like the pixel coordinates to look up on? Because that would give us something different. Oh, okay. Actually, it's even worse than not being normalized. I want them to go from 0, 0 to 1, 1. Okay. So then that should be somewhat easy to fix then. If we just replace all of the negative ones with zeros. Still get that. Where's the blue pixel? Not helpful. Yeah, they have just set these to be ones and zeros. Like we have them in a different order, but we're still covering all of the rectangles, so it should still be drawing. And then, like I'm kind of expecting everything to actually, what are we expecting? I'm expecting like lots of copies of the image to appear, but this isn't the case. I'm expecting like stretched versions of the image everywhere here. I guess technically we haven't actually set the tech coordinate to be that. But like, would that really affect it at all? It seems like it's automatically doing it. Oh, okay. That was the issue. We failed to copy that example. It was a transcription error. That line got lost in translation by Sophia Coppola. Okay. Good, I think, okay, I'm still kind of surprised with this output in that I was expecting a lot of like shrunken, oh no, this is correct, this is the output. Since we render this first by rendering like the outside, the outside big square, which is why there's this blue border here, and then we render it, then we render it like again for the inside, and then each of these 4 separate times. Okay. Okay, this actually seems to be alright. So now if we go to main and actually do assets blue marble .qi, is that not what we called it? Oh, blue dash marble. Great, okay, good. We're like 99% of the way there now. We just need to, well, I mean, we are there. We've now got the textures now being rendered. So this is good. We can try doing this like this blending function now and see if we can. It looked a bit weird and trippy, but fun. So yeah, so what are they recommending? Just multiply it. Just multiply it by the color. Okay. Let's in the fragment shade flat color. So let's see what this looks like. Okay, yeah. Oh, so now we're making like an Andy Warhol kind of art. But this is good. This is good progress. So let's yeah. Like why in the future, I guess I've learned my lesson. In the future, if you're doing texture stuff, as a test image, do not use something with like black borders or that kind of seems black. Since then you can get dimensions wrong and it's actually working and you think it's not working. Just use something bright like red, or we should just have like a debug image we use. Okay, this is cool. Yeah, we might take a screenshot of this. What it's like. Full screen. Yeah. Great. Save this as like Warhol. Okay. Yeah, actually, and so like I didn't realize it was possible just to almost in some sense like generate these Warhol kind of things through a fragment shader this way. But now I like see this, I now see this is like, this is one of the easiest ways of doing this. Like it's, yeah, anyway, let's save all of this. And then we'll think about what to do next time. So let's remove the QI. We should actually, we should start doing stuff for the README. What's the time? Nearly 7. Kind of want to do some exercise. Somehow it stopped raining outside as well. as if that were even possible. And then I don't. Anyway, yeah. Okay. Let's save this and then quit. Got texture. Got blue marble. Texture rendering. Exclamation mark. Looks like. Okay, get that out to the cloud. Okay, so I think next time we will have to eat the proverbial carrots and actually introduce a README for this thing. But otherwise, I feel like we could do a really crude README right now. That's just like, but it's basically 7. I don't, not super in the mood. Actually, let's just plan what we're doing next time. So document sliding puzzle. So okay, so we got this. So we're gonna have to figure out the we're gonna have to start playing with these tech coordinates. So the first thing to do is to split this up into a separate shader. Oh, of course, like it's a game, right? So it's static. Put all of these around. So yeah, so we want to. I don't think I've ever seen a grid puzzle game where the background is pieces of floating on a background. Kind of looks more interesting. So yeah, we're gonna do, instead of each of these being a replica, like the entire texture pasted on, we need to figure out how to get like the correct portions so that the overall image is the one in the background. And then it will almost be done, really. At that point, we'll want to get the we'll need to start doing the win condition logic. That will be like 5 minutes. That's like a trivial, well, that's like a first year or even like a high school exercise. Then after we determine a win condition, I think it would be fun to finish this with some animation. Like all of these things in the background could disappear. The tiles themselves could disappear. There's a couple of things we could. There are a number of things we could do. Yeah, we'll be creative and figure that out next stream. But and then alright, then what else? Yeah, since we're eventually gonna, I guess we're gonna be doing it soon, porting this to the web and the Serenum. I want to do the web first since I want to get, well, like since I want to be able to get web, make games, get demos, or get those games themselves onto the web without using any disgusting like Unity WebDL package. We're using some totally bloated version of Inscripton. We've nearly done that. I think the first step to do that is to make a simple game that we can port. A very long time ago last year, we used the Scott Redig's JavaScript bridge to do that. So we'll probably have to get that alive again. And well, I mean, I think we did one stream. Maybe we'll create some other simpler examples of doing WebGL stuff purely in Zig, not really touching any JavaScript. Maybe we'll do like 1 or 2 streams of that, and then once we've got some textures rendering, once we've got some, it'll just be a repeat of this. Like we'll get some solid, we'll get the pipeline down for, the aim is to create a WASM file that can do all of this stuff. And there'll be some JavaScript linking code, but that's automatically generated by the JavaScript bridge, so we don't have to touch it. And we just want like a WASM file that contains all of this. And then suddenly it's like as portable as you can be. In theory. Okay, but so next time is getting proper texture coordinates, win conditions, maybe we'll be able to do that in one stream, and then some like ending animation. And then, the rest will come later. But thanks everyone who stopped by, and see you next time.